Good day, class. This is, by the way, Stephanie NAPALLATAN, and I'm going to proceed on discussing the measures of position. And again, I am from Metropolitan Medical Center, College of Nursing. Welcome, my awesome students. Let's work together, do our best to learn as much as we can, and respect and support each other through all the challenges. Let's do this. So first, the topic is the measures of position. We will be studying the mathematical concepts and formulas and procedures about the measures of position. We will cover the three topics of it, which will be the quartile, decile, and percentile of ungrouped data. Again, quartile, decile, and percentile of ungrouped data. So for our objectives is that we have to understand first is the measure of position. We will be again studying the three main topics which I have discussed earlier about quartile, decile, and percentile. Next is we're going to learn how to analyze and solve using the measures of position. So first, we have the quartile. So for the quartile is that quartiles are divided into four equal parts with two methods. So again, four equal parts. So the first quartile will be the lower quartile or the Q1, as you can see here, the tree. And then next is the middle, middle quartile, which is the median or the Q2. And the next and the third is the upper quartile or the Q3. So let's discuss more about it because we have two methods of it. What are the two methods of the quartile? So using these methods, we have Mendenhall and Sinkich method, and next is the linear interpolation method. So let's discuss first is the Mendenhall and Sinkich method. So for that, quartiles using this method is that first, for the lower quartile of the Q1, if the lower quartile or Q1 falls halfway between integers, we will be rounding up the answer. So for example, later on I'll be setting for example. So the formula of it is equal to 2, point 25, open and close parentheses, and inside it is n plus 1. So for the Q2 or the median, we had a formula of 0.5, open parentheses, n plus 1, close parentheses. And then for the tree or the Q3 or the upper quartile, we have here is that if it falls between two integers, where we're going to be rounding down the answer. And it has a formula of equal to 0.75, open parentheses, n plus 1, close parentheses. So if you're kind of curious what n is, it is indicated here that n is the total number of data, meaning to say with the data that is informed or the total number of all the data, or let's say the number of the data that we have is the n. Okay, to the summation of it. So let's go ahead and proceed on the first example of the Sinkich method. Mendenhall and Sinkich method. So here we have here, for example, find the quartiles of the scores of 7 students in their 20-item math quiz. So given the data set, we have 4, 8, 12, 15, 2, 7, 21, 5, 9, 19, 16, 6, and 10. So we will have to arrange it in order from 0 to 100 or higher numbers or higher value. So first we have here 2, 4, 5, 6, 7, 8, 9, 10, 12, 15, 16, 19, and 20. So as we have discussed earlier, n is equal to the total number of the data. So all of it from 2 to 21, the number of the data is 13 as you can see here. Okay, at the end of the line. So for the first example is we have Q1 or the lower quartile. As you can see here, there is already a formula here. So there should be an open and close parenthesis again earlier as you have seen on the examples, zero point 0.5 times to the number of the total number of data, which is the n, plus 1. So this one, the n plus 1 should be calculated first. Then afterwards, you're going to proceed on um, multiplying it to zero point 0.5. So as you can see here, the n is 13 plus 1, and then 13 plus 1 is 14, and then you're going to proceed on multiplying it to 0.25, and the number, I mean, the answer is 3.5. So you're going to round it up since this is the lower quartile. So the result is 4. So we need to say that the lower quartile is the fourth data. As you can see, what is the fourth data? We have 6. So the Q1 is 6. All right. So next is the median, or the middle answer of all the data. So what you can see here is that it is different from the Q1 because this one is a zero point 0.5. So they are just the same formula but a different value on the zero point 0.5, 0.75, or in 0.25. It differs in every Q1, Q2, and Q3. So for Q2, we have here is zero point 0.5. So first, again, the same process. We will be adding the 13 plus 1 first, then afterwards, we will have the answer of 14, and it will be multiplied to zero point 0.5. So zero point 0.5 multiplied to 14 is 7. So the data is 7. So what you can see here, let's try to count it. For the 7 data, you will be finding the number 9. So the Q2 is 9. So the value of the 7th data is 9. So let's go ahead and move forward to the upper quartile, or the Q3. So for the upper quartile, we have here 0.75. So again, the same process. We will be multiplying it to 14. So 0.75 times 14, we have here is 10.5. And then the difference between the Q1 and Q3 and the Q2 is we will be rounding down the upper quartile. So once you round down it, even though if it is 10.5, 10.6, 10.7, or 10.9, we will be rounding it down. So the upper quartile data is on the 10th data. So let's try to count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the 10th data is the number 15, or the value of 15 on the 10th data. So the Q3 is 15. So again, let's try to sum it up. Again, for the Q1, we will be rounding it up. For the median, it is the middle data of all of the gathered set in order. So for the Q3, it is that you will be rounding it down. Please take down note of all of those information because those are the key words, or the key principles in the Mendenhall and method, or the rules. So next, we're going to use the linear interpolation method. So first is that the rules are, we'll have to find the difference between two data in which the decimal from it is in between. Next is multiply the results by the decimal part obtained. And lastly, add the answer in step 2 to the smaller number. So let's try it first. So for the quartile, we have a group of students obtain the following scores in statistics quiz. We have the number here and shuffled, or not in order, so we're going to organize it again like we have done in the Mendenhall method. It's just the same. We can do it again here in this method, but there are different rules. So first, we're going to find the lower quartile. So disregard the arrow first. Let's go ahead and solve the lower quartile. We have the total number of data, which is 9. So for the lower quartile, we have Q1, or the position of Q1. We will be using the 0.25 plus n, times n plus 1. So again, the data will be 0.25. So what we're just going to do is that we have it here that in the 0.25, in between the 0.25 data is we have the 3 and 6. Okay, you can go ahead and check the arrow again, or the bracket, the first bracket, and the 3 and 6. So in between the 3 and 6, that is the value of the value of 2.5 data. So what we're just going to use is that we're going to minus the 6 and 5. So 6 and 5 altogether, we will be minusing it or subtracting it. It has the, what do you call this? The result of 3. So 3 is that we're going to multiply it to zero point 0.5, since that is the one here in the zero point 0.5, and then as the rules have informed earlier, so there will be 1.5. So let's go ahead and put the 1.5 below. 3 plus 1.5 is equal to 4.5. So that is the middle data of 3 and 6. It's just like finding the median between the 3 and 6. So the in between of the 3 and 6 is 4.25. So let's go ahead and proceed on the Q3 on the upper quartile. So that third position, or the Q3, we have 0.75 open parenthesis and plus 1 close parenthesis. So we have here is that we had a result of 7.5. So for the 7.5, let's try to find the 7.5 data. So in between here, we have 9 and 9. So first is we're going to solve it here with 10 minus 8 is equal to 2. So the 2 will go down, and then we're going to multiply it to zero point 0.5, which is 1. So we're going to add it on the first data that we have here. That is the 8, and then plus 1 is equal to 9. So meaning to say that the middle data of 10 and 8 is 9. It's just the same with the Q1 as well. It's just that it has a different position and a different number of value of what we're going to multiply it with. So it's 75. I mean 0.75. All right. It's just like finding the median of two numbers on that position, or on that place, or on that position of the data. So, all right, let's go ahead and, and proceed on the next topic. So, for the next topic, we have decile. So, deciles are the values that divided into 10 equal parts. So, as you can see here, we have divided to 10 equal parts, or up until 100%, from 0%, 10%, up to 100%. So as you can see here, starting from 10%, it is called the D1, or the decile 1, up until to the D9 with the 90% of percentage, or the equal value. So how do we compute this? To compute the position of deciles, we will be using this formula. dk is equal to k over 10 multiplied to the to the value of n plus 1. So as you can see here, this is the what do you call this? The formula. So k, if you're confused, what is k? The k is the position of the deciles, and n is the total number of data, just like earlier. So let's have an example here. Decile, a researcher collects data and the number of siblings of SHS students in Luciabad Santos Senior High School. And his study yields that the following, we have the following number here. I will not dictate this anymore, but here it is a shuffled group of number or data. So we are instructed to find a D3, D6, and D8. So in a real equation, it might be a different D4 or D1, D6, D20th up until its limit. So the total number of all of the data is 13. So what we're going to do is we're going to rearrange it from the least to greatest number. Again, from 1 to 10, or maybe how higher it goes. So let's go ahead and find D3 first. So for D3, we have here the formula. We're going to apply it. So let's go ahead and put the 3, or the 3 D3, or the K as 3, and then slash the 10 on our formula earlier. And then what is the n? So the n is 13. So that's why it is here. And then plus 1. So next is we're going to proceed on the process. So 13 plus 1 is 14. And then we're going to proceed on putting it down. So 3 divided by 10 is equal to, yeah, that is the result. So the 3 divided by 10 multiplied to 14 is equal to 4.2. So let's round that down. Since it is 2, it is not a greater number. So we have D3. So it has the number here is or the decile is 3 on the third place on the data. We'll count that the first data is 1, the second data is 2, the third data is 3, and the fourth data is 3 again. So the D3 is 3. So let's try to find the 6. So for the 6, we have the same one. So we're just going to do the same process, and the 8th place it is. So let's try to count it from 4. It is 3. 5 is 4. 6 is 4. 7 is 5. And 6 is 6. So it is the 6th place. I'm sorry, it is highlighted the wrong number. But the D6 or the data of number 6 is 6 as well. So for the D8, it's just the same process. We're just going to replace the N with the value of D, or the what we're going to find, or which data are we going to find, which position. So D8 is, oh, we're going to search for the D8. So we're going to replace the N with 8. So again, the same process, and we have here the what do you call this? We have the answer of 11th place. So let's just count it for 11, and then we can find here that the number or the position of 11th is in the number data of 9. So the value of the 8th place is, I mean, the D8 is on the 11th place with a data of 9. So that is the answer. So let's proceed on the other one. So on other topic is that we have here in the finale with the percentile. So percentiles are the values that divided into 100 equal parts. So how do you compute the division of 100 equal parts? That's a lot, right? So first we're going to compute the position of percentiles using this formula. It's just the same as earlier, but right now we're just going to exchange it with percentile, and we're going to exchange the equal part into 100. Aside from earlier, it was 10. This one is on 100. So K, again, it is the position of percentile. Let's change the value of it. It is now percentile. So PK is equal to K, or the position of percentile, and then is divided to 100, multiplied to open parenthesis to the total number of data, or N, plus 1 and close parenthesis. So next, here is an example. So let's try it. The following are scores and statistics tasks, which are the following, which is again shuffled. So find the value corresponding to the 34th percentile. So let's try to find the 34th percentile in this shuffled number. So the 34th percentile here is that first we're going to do the first step. We have to rearrange all of the values or the scores of the data. So from lowest to highest data again in numbers. So we have here our formula just for reference, and then first we're going to use it. So the K again right now is 34, which is the 34th percentile that we're going to find. P34. So is equal to, let's try to put it in the N as a 34, divided by 100, and then the N is actually 10. So we're going to replace the N into 10 from the formula. So 10 plus 1. So it has a value of 11. So what we're just going to do is divide the 34 to 100, and then multiply to 11, and then this is the result. So the result is 30, I mean 3.74, or fourth place. So the fourth place or fourth position in this data following here, which is arranged already, is number 6 as highlighted here. Let's try to count it again just to make sure. 2 is the first value, 3 is the second value, fifth position is third position is the fifth, or number 5, and then the fourth position is number 6. So we have the value of P34 to 6. So that's the number. All right, so let's resume to the percentile rank. This one, so as you can see, it has a different formula rather than earlier. So what you're just going to use here, what you're just going to do, the percentile corresponding to the given value of x is computed by using the formula following here. We have percentile rank of x is equal to the number of values below x. So mean to say the number of values below the one that has a lower value than the number
プレイヤー諸君は
itself,
すでにメイン
plus 0.5. 5 over n and overall multiply to 100. So we have an example for that as well. So for that example, we have here is that we will need to find the percentile rank and the test scores of 38 in the dataset of the shuffled number again below. As you can see, I have arranged it from the lowest to the highest number. So the total number of the data we have is 7. So first, we're going to use the formula that we have earlier for the percentile rank. So as you can see here, percentile rank of 38 is equal to, let's say, 3, which is the number below it, and then plus zero point 0.5 divided by the n. Or what is the n? It is the 7 multiplied to 100. So it is equal to 50%. So the percentile rank of a test score of 38 is 50% in this value. So again, the median or the rank of 38 is 50%. So that's all. Thank you so much for listening. I hope you learned something. Bye.